All right, this is Unit 3, Lesson 3 for our Precalculus 12 class. The unit is called Exponential and Logarithmic Functions. The lesson is called Solving Exponential Equations by Finding Common Bases. What we're going to learn in this video is how to solve equations where x is the exponent. So consider the equations 2 to the power of x equals 32. Now, if you know your exponents, you can kind of figure 2 to the power of what equals 32? Well, 2 to the power of 5 equals 32. And so I can say that to set this up, to think about this in a way that's going to help us solve more complicated problems, I can think of 2 to the power of x equals 32 as 2 to the power of x equals 2 to the power of 5. And so because these two values have these two expressions have a different, or the same base, they both have a base of 2, and they have different exponents, I can say that these exponents must be equal to each other. If these statements are equal with the same base, then their exponents must be equal. So therefore, x must equal 5. Just making an equation out of the exponents. Now I could do the same process with 2 to the power of x equals 1 over 4. 1 over 4 is equal to 1 over 2 to the power of 2, which is equal to 2 to the power of negative 2. So I know that x must equal 2 to the power of negative 2. Let's look at some more examples here. So if I have 4 to the power of 2x minus 2 is equal to 32 to the power of x, I could take the bases of 4 and 32 and write them as powers with base 2. So 4 is 2 squared and 32 is 2 to the power of 5. And now we have our exponent properties here. So a power to a power means you multiply powers. So 2 times 2x minus 2 is 4x minus 4. And 5 times x is 5x. So now we have an equation with common bases. And since the bases are common, then we can say the exponents are equal. So 4x minus 4 must equal 5x in order for this equation to be true. So now we're working with this equation. We can solve for x. And I can do that algebraically by subtracting 4x from each side of the equation. Similarly, on the second example, 243 and 81 are both multiples of 3. We have 3 to the power of 5 is 243, and 3 to the power of 4 is 81. So I can write these as powers with base 3. And I can simplify the exponents by multiplying each side. Some distributive property. And then I can say, since I have common bases, I can set the exponents equal to each other, do some algebra, and I can solve for x. X equals negative 5. All right, takeaways. Exponential equations can be solved by finding a common base. And you might be asking yourself, what if I can't find a common base? What do we do then? And then now we have a strange, funny feeling that we're going to find some new function that'll help us answer that question. But not for now. For now, find some common bases.